Welcome back to the next installment of the AP ECE Chemistry Chapter 16 Precipitation Equilibrium Problem Set, and I wanted to revisit Problem 57 because it was a little cramped at the end of the last one. In Problem 57, I had some labeling issues here. This should not be sulfate. This should be the barium ion because you're trying to find out what the barium is. You know what the sulfate is, so this is Ba2+. And that makes this thing at the end here as well. The molarity of the barium. Ba2+. Apologies for that. This is a pretty long and involved problem, and I boofed it right at the end. Alright, let's take a look at problem number 63. Problem number 63 is a pictorial problem. You're given a solution that appears as having 4 squares and 8 circles, and you're also told that when this does precipitate, it precipitates in a 2-to-1 ratio with 2 circles for every 1 square. So you're given, this is the saturated solution, and it can only contain 4 squares and 8 circles. And then you're given a picture with 6 squares and 12 circles. So you're only able to maximally put in your 8 circles and 4 squares into the solution, so the rest of the stuff, 2 units of this substance, needs to sink to the bottom and be a precipitate. Let's take a look at problem 67. In problem 67, you're considering the equilibrium curve for silver chloride. You're asked which are true about the solution at point A in the curve, so you're focusing on this point right here. The first one is a statement about the solution being at equilibrium. That's a true statement. The next one is you're asked if you add NaCl would increase the Cl concentration in solution. That's a true statement too. Anytime you add NaCl, that will fully dissociate and increase this chloride ion concentration. Part C, adding NaCl increases the silver ion in solution. That's false. If you increase the chloride ion concentration, it'll actually create more AgCl in a solid form and decrease the silver ion concentration. Part D, adding silver ion results in silver chloride precipitation. That's a true statement based on Le Chatelier's principle. Should push it back to the solid. And then adding NaNO3 does not change the concentration of the silver or the chloride, and that's true as well. No substance will bond with each other out of those pairing sodium and nitrate with silver or chloride. Last but not least, let's take a look at 71. In problem 71, you are considering a solution that has quite a few things in it. It's got iodide ions, silver chloride as a solid, silver nitrate dissolved, and then also chloride ions that come from the dissociation of the AgCl. You want to find out what the iodine ion concentration is just as AgCl begins to precipitate in these combinations of things. So again, write an equation to start. AgCl will dissociate to Ag plus and Cl minus with a KSP of 1.8 times 10 to the negative 10th. And you also have AgI, silver iodide solid, dissociating to Ag plus and I minus with a KSP of 1 times 10 to the negative 16th. Comparing those KSP values, because the KSP of AgCl is greater than the KSP of AgI, AgI should precipitate first as a lower value. So your task is to find out what the silver concentration will be as the AgCl just begins to precipitate, and then you can work to find out what will happen with the iodide. So the KSP again is 1.8 times 10 to the negative 10th for AgCl. There's your KSP expression. You rearrange that to solve for your Ag ion, knowing what your chloride ion is and knowing what your KSP. You're told what your chloride ion is back up here in your original given information, 0.020 molar. You can find out that the silver ion concentration will be 9 times 10 to the negative 9th molar. Now plug that concentration of the silver into the KSP expression for AgI, and you can find out what the iodide ion should be when the precipitation just begins. So you rearrange your KSP expression, you solve out that it's 1.1 times 10 to the negative 8th molar iodide.